All right, let's look at three-dimensional rectangular coordinate systems. Okay, just like in two-dimensional, we use x, y. Here we use x, y, z to describe a point in 3 space. And these are called ordered triplets. 2 ordered triplets are equal if and only if their corresponding coordinates are equal. The origin is in two-dimensional 0, 0. Here it's 0, 0, 0. And x, y, and z are axes. Now there's 2 ways that we're going to talk about this. There's a right-handed system and the reason it's called that is because if z is pointing up and the x-axis points out of the plane. So if z is pointing up, pretend you have your thumb there and your thumb's pointing up, then you see your fingers in your right hand are wrapping around to the right. So your fingers, if your thumb is pointing up, then your fingers are wrapping around to the right. And so the x-axis is coming straight out, pointing at you, and it's wrapping around to the y-axis, which is in the plane. So the zy, this is the zy plane, is in the paper, is flat in our paper, or it's pointing up if you want to think of it like that. And then the x is coming out straight at you. Now the left-handed system, again, z is pointing straight up. That's your thumb. Pretend your thumb's pointing straight up. And this is your left hand now. And your left hand is, your fingers are going left, so they're wrapping around this way. So this time, the x-axis, start from the x-axis, is in the plane, and the y-axis is pointing straight out at you. So the x-axis is here on your palm, end of your palm, and in this case it's at the end of your palm, and it wraps around left to the y-axis. So that's why it's called a left-handed system. Now let's find a point in this. We're going to use the right-handed system, and suppose we have the point 2, 3, 4. Now these are hard to draw in three-dimensional, so I'm going to use Maple sometimes to draw these pictures. But here we can draw this one. This is the z-axis. The x-axis is pointing out. This is the y-axis. It's important we label these. And the x-axis is pointing straight out at us. And these are all 90-degree angles. So we're going to go 2 units on the x-axis, 3 units on the y-axis. So it's going to come out here. And then we're going to go up 4. So from this point, we're going to go up 4. It'll be right here. So I know that's kind of hard to see, but we're going to go out 2 on the x, out 3 on the y, and up 4. Now if we draw a little box here, it's going to come out and be that point right there. Okay. So now instead of just 4 quadrants, we have 8 octants. And the first octant is where x, y, and z are all greater than 0, and that's called the first octant. And that's where there's a z is positive here. This is where y is positive, and x again is coming out straight at you. And so that octant is this, it's like the space right there, if you want to think of a cube, but it, goes out to infinity. So, and again, remember the z-axis extends, and that's how we get our 8 octants. Okay, let's look at the distance between 2 points. Let's see how we do the distance between 2 points in 3 space. Well, it's just the same as the distance formula in 2 space, except we have 3 coordinates. So the points that we have are x1, y1, z1, and x2, y2, z2. And we just do it like that. And you can get that from the Pythagorean theorem. I'm not going to go through that. You can read that in the book. So that's pretty easy to remember because that's just follows from 2-dimensional distances. Now, here we have planes in 3 space. So if we sketch y equal 2. In 2 space, that's just a horizontal line at 2. But this is 3 space. So that means x and z are not fixed. X and z can be anything. But y is stuck at 2. So here's z, here's y, and x is coming straight out at us. Y is 2, but x can be anything. So this can go forever. And z can be anything in both directions. So what we have is we have a plane through here, through y equal 2. So we have a plane parallel to the x, z plane. And it's going through the point 0 to 0, which is right here. So it's kind of hard to draw, but we can get an idea of what that is. Let's try x equal 1. So if x equals 1, y and z can be anything, so this plane is going to look like this, going through this point. So it's a plane parallel to the y-z plane through the point 1, 0, 0. And x equals, or z equals 3. So z is stuck at 3, and it's going to be flat, and it's through this point. So we have a plane parallel to here. This is the x, this is the xy plane. And it's through the point 0, 0, 3, or up 3. So there's some pictures. Now let's go back to the distance formula. So just like with circles, remember a circle in 2-dimensional, what the formula is this, where the center of the circle is HK and the radius is R. Well, for a sphere, because that's what we have in 3-dimensional, it's just going to be almost the same thing. You probably can guess what it's going to be. And here the center. And again, this is just using the distance formula. And the radius is R. Okay, and then you can look at some of the example homework problems where I do the even problems, and that should help you with some of your problems that you have to do.